Welcome to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
5.7. Using the second derivative test to determine extrema. Second derivative is looking to find local maxes and mins. This is a great visual to look at for just references or if you're struggling. An easy example would be f of x equaling x cubed minus 6x plus 5. Your first step would be to find the first derivative, and then you'd set it equal to 0, and then you'd find what x would equal, which would be plus or minus root 2. You would then find the second derivative, and you would plug both the positive and negative versions of x into it, one being less than 0, one being greater than 0. For the one less than 0, if you look at the picture on the right, f double prime less than negative on the left side of that picture would result in a concave down relative max function. And if you look at the right of that picture, for the greater than 0 or positive, it would be a concave up relative min. A good FRQ example, this is part B, so in part A you would have already found f prime and f double prime. Your first step would be to plug in 1 to find k. K would then be 2. Your second step would be to plug k equaling 2 and x equaling 1 into f double prime, which would then give you 1/2. But really all we're looking for is if it is greater than or equal to 0, which in our case it is greater than 0, which would result in f having a relative minimum at x equaling 1 by the second derivative test. And here are the scoring guidelines. We went through all those points, so we would have gotten 4 out of 4 on this. If you needed a little extra, you could draw a graph like this. And the reason why it's a relative minimum is because it's greater than 0. So if you look at the right, when f double prime is positive, that is why it's a relative minimum, because you see how it's on the graph, relative minimum. And this is a 2007 FRQ number 6. Another good FRQ, which it's further along in it as well, so you would have already had some information. And for what we have now, the point where the line is tangent to the curve is horizontal at pi over 2, 2. And that is the first derivative. And then we'd want to find the second derivative, which to find that you would just do low times the derivative of high minus high times the derivative of low over the bottom squared. And then your second step would be to plug in the points that we had, which would be pi over 2 for x and 2 for y, which would then give us negative 14 over 49, and which would give us a relative max because it is less than 0. And if we go back to C, you see f double prime when it's less than 0 would be a concave down relative max function. So that would be completely right. And I do not have the scoring guidelines for this because this one is a very new problem. It is 2021. So if you'd like to see the scoring guidelines, that will probably be out, but it takes a few months after the test is out. But this is number 5 on 2021. Thank you for watching, and I hope you learned something.